Hello everyone, welcome to the introductory video series of Basic Electrical Engineering Lab. Before proceeding to our first lab experiment, let us first get to know how to measure two of the very basic electrical quantities, which are voltage and current, as they both play a very important role in analyzing any given circuit in our experiment. See, measurement of voltage is one of the very easiest and one of the most common measurements which we come across in our labs, or we can say that in our day-to-day lives. Well, it can be easily done with the help of a analog or digital voltmeter, or we can say simply by a multimeter. Only thing that we have to keep in mind is that the voltmeters are always connected in parallel with the element whose measurements have to be taken, and it can be simply put into action by placing the voltmeter across the 2 points where the voltage is to be measured. So this is how your analog voltmeter looks like, and this is how your digital multimeter looks like. So in this video we'll be using a digital multimeter for the measurement of voltages. Why? Because it has several advantages over the analog multimeter. Firstly, it can measure DC as well as AC voltages, and it can also measure other quantities such as current, resistances. It can tell you the terminals of a diode, of a PN junction diode, and it can also tell you the terminals of a transistor. Let us now see how actually measurement of voltage takes place. So I'll be considering a simple series circuit comprising of three resistances R1, R2, R3 and a source Vs. Alright. So as I've discussed in previous slides also, the measurement of voltage, only thing you have to keep in mind is you will always have to connect your voltmeters in parallel of the element. So let us suppose that we have to find out voltages V1, V2 and V3 utilizing a multimeter, whereas V1 is the voltage across resistance R1 and V2 and V3 are the voltages across resistance R2 and R3 respectively. So what I'm going to do is, for example, let me say that this is my voltmeter. So for measurement of voltage across resistance R1, what I'm going to do is I'm simply going to put one probe of this voltmeter here and another probe of this voltmeter here. Fine. And simply this step could be followed, or you can repeat it with for the resistances R2 and R3. Fine. So let us now check how actually it looks like onto the breadboard, because your initial experiments will be conducted on breadboard itself. Fine. So what I have done is I have made this circuit onto the breadboard. Let us verify if this is correct or not. So these are resistances R1, R2 and R3. Three random resistances have been chosen, which have been placed in series. You can clearly see that the terminal number 2 of resistance R1 is in series with R2. Why? Because it is in same line with the resistance R1, and similarly for resistance R3. We know that for this column the wires are connected internally, which means this column is internally short. Okay, so as far as connection of voltmeters are concerned, what I've told you in previous slide was that you simply have to put your voltmeter in parallel with the resistance whose voltage has to be found out. So let's suppose we have to find out the voltage of across resistance R1, and this is your 9-volt supply. So what I have done is, this is the positive probe of voltmeter and this is the negative probe of voltmeter. So I'm taking red color for positive probe and black color for the negative probe. See, so let us say this is your red probe and this is your black probe. So the red probe is connected to the first terminal of R1. Let us verify it. red probe is connected to the terminal of resistance R1, and for connection with the first terminal of resistance R1, I only have 3 options left. So therefore I connected it here. Okay, meaning now the positive terminal, or you can say the positive probe of the voltmeter, has been connected with the first terminal of resistance R1, and now the black probe has to be connected with the second terminal of resistance R1. So let us verify that also. You see, this is the black probe and it has to be connected with the second terminal of resistance R2, which is here. So only options left with me are this hole, and this hole. Why only these 3 holes? Because if you connect this probe anywhere else, it will not be connected with terminal number 2, because only this column is internally short. So you had to connect it in these 3 holes only. Therefore I connected it here, meaning now whatever voltage is across resistance R1, your reading will be shown to you on the display screen of your voltmeter. And these steps can be easily repeated for resistances R2 and R3. Fine. If you want to measure voltage across resistance R3, what you are going to do is connect the voltmeter in this fashion, and it will give you the voltage across resistance R3. See, if you do not want to insert the probes of the multimeter onto the breadboard, what you can do is you can also measure the voltage by simply touching the probes of the multimeter on each end of the resistor as shown in this figure. All right, which is a simpler way of measuring the voltage. So now let us proceed to the measurement of current. So for measurement of current, one thing that you have to keep in mind is the ammeter is always connected in series with that element. Fine. In the previous method, which was measurement of voltage, what we did was we connected the voltmeter in the parallel of that element. But now in this case, what you are going to do is you are going to break the circuit open and insert the ammeter in series with the circuit, so that all the current which has to flow through the circuit also have to go through the meter. Then only the meter will be able to tell you as to how much current is flowing through that element. Okay, so because measuring current in this manner requires the meter to be part of the circuit, it is much more difficult type of measurement than voltage or resistance. Okay, so for measurement of current, I'll take the same example, which is 3 resistances in series and a voltage source. Okay, so now the question arises, what will happen if I connect the ammeter in parallel like we did in previous case? For example, if you connect a ammeter in parallel with the element, what would happen is, actually what happens is, the ammeter has a very negligible resistance. So you know a very interesting property of current. What happens is current will always try to follow the path with least resistance. So let us say I current is flowing through here, and we are interested in finding out the current through this resistance. So as soon as the current I will reach this point, it will try to take this path and return to its origin. So we were interested in finding out the current through resistance R1, but current was least bothered to pass through R1. Therefore, current did not pass through resistance R1. Why? Because the ammeter which was supposed to be connected in series, but you connected it in parallel. So the current decided to take the path of least resistance and chose to flow in this manner. All right. So this method is wrong. So what is the correct method? Let us see. Correct method is to break the circuit. As this is a series circuit, I'll only have to insert only one ammeter because the current flowing in each of the resistance R1, R2, R3 is same as they are in series. So I can break the circuit from anywhere, meaning that I can insert my ammeter anywhere in the circuit because current flowing is same in all the three resistance. So I decided to break the circuit from here. Okay. So after breaking the circuit, what I am going to do, let us suppose this is a ammeter and it has two probes, positive and negative. So positive probe will be connected in this manner and negative probe will be connected in this manner. Now you can clearly see that the ammeter is in series, or you can say that the ammeter is part of the circuit. Now let us check whether the current is flowing through resistance R1 as well as ammeter also. So current has only one path to follow. Now current will start flowing from here, go like this and come back to R2, R3 and back to its source. Okay, so this is what the actual connection diagram for measurement of current looks like. So if I draw it more neatly, it would look somewhat like this. Okay, meaning that the ammeter is now in series with the resistances. All right, so let us see how this circuit looks like onto the breadboard. So this was our original circuit. I have drawn it on the breadboard. See, let us verify if there are three resistances or not. Or so this is your resistance R1, R1, I'll write it again. This is your resistance R2, this is your resistance R3. So they all were connected in series before breaking the circuit. After the breaking the circuit also they are connected in series, but the connection is different now. Okay, so what I have done here is, earlier this resistance R1 was supposed to be connected in this column. Okay, but now what I have done is I have taken one end of the resistance and connected it here. Okay, same has been done in this diagram also. Let us suppose this is your terminal number 2. So this is your terminal number 2. Okay, and this is the positive probe of your ammeter. See, so what I have to do is I have to connect terminal number 2 with positive probe of the ammeter. Let us see if it has been done here or not. This positive probe has been connected with the second terminal of resistance R1. And let us see what happens with the negative probe of the ammeter. Negative probe of ammeter is to be connected with first terminal of R2. So this is the negative probe of ammeter. Where is it supposed to connect? It is supposed to be connected with first terminal of resistance R2, which is here. So I can clearly see that it has been connected with it. Okay, so let us check whether the circuit has been completed, and our initial condition, or you can say our original condition, which was to pass the current through resistances as well as through ammeter has been fulfilled or not. So current has to take this path. So let us verify it in our breadboard diagram. So breadboard diagram is somewhat like this. Let us say this is positive terminal. So current will start flowing from here. It will go from resistance R1. It will pass through ammeter and passing through the negative probe. It will go again to resistance R2 onto resistance R3 and back to its source. Okay, meaning these two circuits are equivalent, but only thing we have to keep in mind is we'll have to break the circuit and make the ammeter part of it.
So let us now see how a voltmeter is inserted into the circuit for measurement of voltage. And for that, let me take a simple example. I have drawn a single series circuit having three resistances R1, R2 and R3 and a voltage source Vs. So as you can clearly see here, I have already made the required circuit onto the breadboard. This is resistance R1, R2, R3. So the object of this activity is to find out what is the value of voltage source given to the circuit, what is the value of voltage again R1, what is the voltage in resistance R2 and what is the voltage across resistance R3. So as we all know that a voltmeter is always connected in parallel of the element through which we want to calculate the voltage. So let us first calculate as to how much source is being given to the circuit. So theoretically, I'll be connecting my voltage meter, or you can say voltmeter, somewhat like this, meaning the positive terminal of my voltmeter will be connected to this end and my negative terminal of my voltmeter would be connected to negative end of the battery. So let us do that in the circuit. This is my positive end. It will be going to the positive end of the battery, and this is my negative end, will be going to the negative end of the battery. So I can clearly see here the voltage is approximately 10 volts, meaning the circuit has been provided with 10 volts of supply. So my first object is complete. Let me now calculate the voltage across resistance R1, and to do so what I am going to do is I am going to connect the voltmeter as shown in the diagram, that is in parallel with the resistance R1. For doing so, what I am going to do is connect the, let me take the positive end of the battery and connect it to the first terminal of R1, which is here, and second terminal goes so in this manner. I have connected the same circuit diagram which I have drawn here onto the breadboard. My positive end of voltmeter is going to one end of the terminal and negative end is going to the another end of the terminal, and it is giving me a voltage of approximately 4.07, meaning the voltage across VR1 is 4.07. And similarly, let me now measure the voltage across resistance R2. For doing so, I'll connect the voltmeter in parallel with R2, which will look somewhat like this. So I can clearly see here my voltage across resistance R2 is approximately 2.90 volts. Alright, and my last object of this activity would be finding out voltage across resistance R3. For doing so, what I am going to do here is I'll connect the voltmeter in parallel with resistance R3, somewhat like this. So you can clearly see the voltage given to me is approximately 2.89 volts. So in this manner you can calculate or you can measure voltage across any element. Let us now move on to the measurement of current with the help of a ammeter. Alright, for that what I am going to do is I am going to take a simpler circuit which looks somewhat like this. I have taken a voltage source, I have taken two resistances, resistance R1 and resistance R2. So measurement of voltage was quite easier. What you had to do was, all you had to do was connect the terminals of the voltmeter across a particular resistance and it gave you the value of voltage. But whenever we are supposed to measure current, the ammeter is always connected in series with the circuit, meaning the circuit would be somewhat like this. Alright. So for doing so, what I am going to do is I am going to break my circuit from here and insert a ammeter in between. So this is my final output, which would look like, so I'm going to break the circuit here and insert a ammeter here. Let's say this is the positive end of the terminal and this is the negative end of the terminal, and then I'll continue the rest circuit as it is. So what I have done here is I have taken my ammeter and inserted my ammeter in between these two resistances, meaning that I have inserted my ammeter in between resistances R1 and R2. So the direction of current would be somewhat like this, meaning the current would have to go through the ammeter to be measured. Let us see how it is done in case of practical example. Okay, so this is my normal circuit, normal series circuit, in which there is a resistance R1 and a resistance R2 in series, and positive end of the voltage supply is going to the first terminal of R1, I can see here clearly, and negative supply is going to the another terminal of resistance R2, which is here. Okay, so now this is the positive terminal of my ammeter. So what I am going to do is I am going to take out one terminal of resistance R1 and put it somewhere else. Somewhat like this, and I am going to connect my positive end of the ammeter near that terminal so that they are in continuity. Okay, so my circuit is, one portion of my circuit is completed. One terminal of R1 is connected to positive end of the ammeter. Now what to do with the negative terminal of a ammeter? So negative terminal of ammeter will go to another terminal of R2. So this is the negative terminal of my ammeter and it is connected to where my first terminal of R1 is. So my first terminal of R2 is here. So let me connect it here. So I can connect it anywhere in these remaining four holes so that they are in continuity. So I can clearly see here the current through my resistances is approximately 26.9 milliamperes. Alright, meaning that current flowing in the series circuit is 26.9 milliampere. Alright, and there is no need to find out resistance across R2 because these two resistances are in series, meaning the same current will be flowing through resistance R1 as well as resistance R2. So in this manner you will measure your current in all the upcoming experiments.